Good morning. So I actually have with me Rob Nolen as well. So he's one of my coworkers. So he's a senior solutions architect. I am a partner solutions architect dedicated to the VMware partnership. So I guess before we begin, just to get an idea of where everyone stands as far as their VMware knowledge, AWS knowledge, how many people today have a VMware-based environment? How many of you are using AWS today? And I would say, how many of you are looking at VMware Cloud on AWS? All right, good to know. So then I guess from those who answered that are using VMware today, how many of you are at vCenter Server 5.5? Are any of you at 6.0? What about 6.5, 6.7? All right, great. So we'll get into some of the details around compatibility, functionality, how that works as well from a high level. And then also what we're looking to do today is to help you out as far as understanding what correlates in a VM world with the AWS naming conventions as well. So from the types of services available, how do they equate to each other, what do they mean, how do they relate to each other, and we'll go through some of that with you. Do you want to introduce yourself?
Yeah, so I'm Rob Nolen. I work in our DoD team here at AWS, and so we're seeing a lot of customers who've used VMware in not just in a data center, but in other places as well. So having VMware on AWS, I think, is a really powerful solution. And I think what really is exciting for me, I've spent most of my career working with VMware as well, is the fact that you can leverage the power of native AWS services, leverage the power of native AWS scale, but still keep it inside the existing kind of operational framework that you've established around your VMware environment. So like Samir said, we really just want to help you guys understand all of the different services and terms that we have in AWS. And so as you're because these two systems are designed to be very tightly coupled, right? So you really need to be able to understand both of them to get the full benefit. Mm-hmm. And then especially in public sector, we also have to really consider security and compliance too, right? So leveraging AWS services to help with that, I think, is going to be really powerful for you.
Yeah. So we'll cover why do you care, VMware Cloud on AWS, computing, network, storage, what's next. As Rob did introduce himself, here's some of his credentials. As you can see, he's also VCDX, former EMC V specialist. I'm also former VMware as well, so been hands-on with the products. We both actually worked together prior to AWS as well. So as far as why are we here, the cloud is a new normal. Historical partnership with VMware is coming to play with the whole partnership with VMware Cloud on AWS. And we want you to take full advantage of the integration that it offers. So just because you have the VMware stack in AWS from that perspective, now you do have the option to utilize native AWS services with your VMs. So we're not saying that you have to necessarily change your VMs, but you do have the flexibility to add on additional services that can benefit your VMs from that perspective. And then also we'll cover a place to start as well, where this can benefit you by moving to VMware Cloud on AWS. How do you begin, and what can you do after that?
Yeah, just to add a couple of points to that, cloud is the new normal. That's a line that our CEO says, but yeah. I think that it really is true now, right? Because it's not a case anymore of why should I use cloud or can I use cloud, but it's really why not, right? A lot of customers are having, or a lot of organizations we work with are asking themselves, why am I not going to the cloud? And then using VMware, I think, the neat thing about this is the first time ever that Amazon has let another third party build something on bare hardware in our data centers. Yeah. This offering is unprecedented as far as the partnership between an existing on-premises software vendor and a hyperscale cloud provider, right? So it's a really neat time and a neat product to get into.
Definitely. So as far as VMware to AWS conceptually, we'll look at from the VMware side to AWS side. So with VMware, you have your clustered data centers. With AWS, you have your regions, availability zones. So think of, with regions, we have multiple regions throughout the world today. And within those regions, we have clusters of data centers, which we call availability zones. And then with VMware, you have your distributed switch, or you might be even utilizing NSX. In the AWS world, you're going to utilize VPC, which pretty much covers the whole networking space within your AWS account. You do have the functionality that you're familiar with as far as from networking concepts. If you want to set up security groups, you can do that also within your VPC. If you need to customize your route tables, you have the functionality to do that as well. Providing public IP addresses to instances, you do have that option as well. If you're looking to utilize something like an ALB, application load balancer even, you can do that as well on the AWS side. So with VMware, you have your port groups. With AWS, you have your subnets that are available to you to customize as needed. And then on the VMware space, you have your firewall. On the AWS side, you have security groups. So again, being able to customize that as needed, as granular as you want to. And then with VMware, you have the hypervisor ESXi. On the AWS side, you're going to utilize EC2 instances. And with VMware, you have your virtual machines. On the AWS side, you're going to have those instances, so EC2 instances that come into play. And then with VMware, you're going to have your VMDKs. With AWS, you'll have EBS volumes that you can have your EC2 instance access as needed as well.
So, AWS deploys infrastructure globally. And you can see here that we have, data centers on pretty much every continent at this point except for Antarctica and Africa. And like Samir said, in each of those different regions, we create what's called an availability zone. And an availability zone is basically a fault domain, right? So you think about designing for fault-tolerant infrastructure. I want to make sure that I have hardware distributed across multiple physical facilities. And so in this case, each availability zone is an isolated domain for you to deploy infrastructure in. So they're isolated from a power perspective. They're isolated from disaster planes. So they're not in the same flood zones, and they're not on the same fault lines. If a single availability zone ever became unavailable to you, any infrastructure that you deployed in the other availability zone would still be available. So inside of those availability zones, you're going to place your different infrastructure. Oops, a little too fast. So in the event that you lose a server or you lose a cluster in availability zone A, availability zone B is there for you. Now, one thing to keep in mind is when you put data in a specific region, the region is a logical boundary for your data and your services, right? So if I put information inside of, say, the US GovCloud region in Oregon, and then I have a security or compliance guy come to me and say, hey, how can you be sure that Amazon's not going to replicate that data over to Europe? We keep a boundary around those services in that region. That boundary is the place where we tell you, hey, look, if you want to move data out of this region, you're the one that's going to have to do it. I may protect information inside of these different availability zones. Like, for example, with AWS S3, if you write data to AWS S3, I'm going to protect that data across multiple availability zones automatically. But it stays inside that regional boundary. That make sense? Yes, sir. So the question is, would I have access to the data that was protected across all availability zones? And the answer to that is yes, because behind the scenes, we're doing that for you. With S3, for example, if you went to go grab a file, and again, let's just hypothesize that one availability zone became unavailable for a short period of time. When you went to grab that file from S3, it would automatically know that, oh, I can't go there to get that copy of that object, so I'm going to go grab it from the other copy that I have. And that's all taken care of for you under the hood. Right.
Yeah, so with VPC networking, your VPC is your private cloud network in that case. So on the AWS side, you are given a VPC, and you'll utilize that from a networking concept as well. You can divide it into subnets as needed. You can take care of your routing as needed. You're going to have your security groups and access control lists as well. And then any type of adding that you need to do, you can also do that within your VPC. If you want to modify or go through the egress options as well, you do have options to do that. So with your VPC, pretty much you're going to have that as far as in your AWS account within your particular region that you specify as well. And then you could have multiple regions, multiple subnets as needed. In this case, your EC2 instances, let's say, are existing in here as well. And then you can set up the security groups as needed. So if you want to have certain EC2 instances talk to other EC2 instances or not even communicate with other resources, you can set that up as well. And then you do have full functionality to modify the routing as well that's needed to that. And then if you want to have your EC2 instances communicate with the public internet, let's say you're giving them a public IP address, and you need someone to access that, let's say an EC2 instance from public internet, you do have the functionality to do that as well. And then if you want to lock it down from a security perspective, even from open internet access, you do have the full functionality and feature set that's available to you where you can lock it down as well. So it's not like everything has to be open to the public internet. You do have the functionality and feature sets available to you to lock down what you want to lock down.
Yeah, if you just go back real quick.
Yeah.
A couple quick things on this too is that VPC is our, is our software-defined networking solution that is your networking enclave in the cloud. I like to equate an empty VPC to if I just took a layer 2 switch, right? And I put it on a table and I plugged it in. That's what you have with a VPC. It's completely isolated. I decide what uplinks to that VPC. I decide what devices I put in it, right? So one of the great things about VPC is that it's such a powerful technology that we've actually, our FedRAMP and DoD accreditations equate it to physical isolation from a network perspective, right? It's very, very powerful, very secure. The security group construct is a great way to do defense in depth and layered communication inside of application tiering, for example. And then again, VPCs do not connect to the internet by default. The default one does in your account when you first create it, but let me just give you a free piece of consulting advice. Delete that default VPC. Yeah. You don't need it, right? Use everything you should be doing in VPC should be defined specifically for your purposes. The default VPC exists primarily to make it easy for you to get started. So if you're a neophyte to AWS and today's your first day, you can get up and running with an EC2 instance really quickly, but when you're building an infrastructure that you're going to submit for an ATO or something like that, you really want to build every one of those components individually and have a way to define that. So with that little lock icon up there in the upper right-hand corner, that's signifying a gateway. We have a couple of different kinds of gateways. We've got internet gateways. So if I am building like a blog or something that's going to go on the internet, I can have my instances access the internet directly. But I can also have that terminate on a VPN tunnel or on a direct connect, which is a direct network connection from your environment to ours. Right? So just the reason I'm kind of hammering on this point is I want to make sure everyone's clear. As you go back and you talk to your teammates, you talk to your management about using AWS, by default, we are not connected to the internet. Right? You can completely bypass the internet altogether if you want to and just use private networking. So,
yeah. So we'll go into some of the compute functionality as well. So with AWS, you're going to have Elastic Cloud Compute, which is available to you. So the EC2. This came out to be in 2006, one of our most popular services, obviously, along with S3 as well, where customers can just go to the console, deploy an EC2 instance, and think of it as deploying a VM. It's up and running. You specify configuration or instance type in this situation. You would specify what you need from that point. So when you specify the instance type and go through the settings as far as what network it should be related to, or connected to, and all that, if you needed to have even like a public IP address that's accessible from the public internet even, you can modify that as needed. You can set up security groups that are related to it as well. So again, coming back to Rob's point where it is fully flexible from that standpoint and secure from that standpoint as well. The instance is a foundational unit. It's pretty much a building block for the rest of the AWS services that you can utilize as well. So with an EC2 instance, if you want to, say, have it interact with a database, RDS, you do have the functionality to do that as well. If you want to have it even interact with other types of services, you do have the option and functionality to do so as well. So think of Xen KVM as for being the hypervisor, underlying hypervisor that's being utilized to support this. So it is pretty much customized, obviously, in that situation, and then utilized from an AWS standpoint. So we do offer for EC2 instances what are called families or sizes in this case. So you do have multiple options to pick and deploy your EC2 instances from. So for example, there's an extra large or X large size. You could have multiple X larges exist, and you can scale out to many X large instances. They could be of different sizes as needed. You do have the option to even change the instance types as needed. So let's say you start off with something where it's not best fitting your needs from a memory aspect or even from a compute aspect. By all means, you have that flexibility to just change that instance type as needed as well.
Now, one thing I'll mention as well about families, right? So a lot of times I meet customers and they say, oh, your cloud performs terribly. Yeah. And I look at them, I'm like, what do you mean? And they're like, well, we did a performance test and it just, after about 15 or 20 minutes, the performance just went down badly. And the reason is because, and we have a lot of different instance families when you go to launch an EC2 instance from the console, and the first ones are our T2 family. The T2 family is a special type of instance that we use we call burstable performance, right? Where there is a mechanism that basically gives you the ability to get more power, more cores, faster processors for less money in exchange for a promise that we're going to typically keep our workload around 30 to 50% utilization. And if I need to go above that for a certain amount of time, I give you the ability to burst, but over time, I may throttle that down. That's the one instance that I actually do that with. The rest of our instance families are what you pay for is what you get. So if you ask me for 2 physical cores, I give you 2 physical cores. I don't do gang scheduling like ESX does, right? I give you 2 physical cores. They are yours. Same thing with the memory. But so the reason I bring this up is that if you don't select the correct instance type for your use case, right? Let's say I'm doing a web server or a domain controller, or I'm building a high-performance computing cluster. If you select the wrong instance type, not only will you have potentially performance that is not acceptable for your use case, but you also may end up paying more, right? If you put an IIS server that gets 10 hits a day on a C4X large, you're paying a lot more money for that than you would if you just put it on a T2, for example, right? So understanding those instance families, like I get paid to memorize those numbers, the names, but we have really great website that has all that data on there. So just when you're getting ready to fire up some infrastructure in AWS, or you're getting ready to, experiment, just take a look at those families and make sure you understand which one you're using. Because sometimes matching up the cores and the memory that I use on-prem to the instance family type, it may not match exactly, right? But you want to make sure you're using the right family for the right purpose. Definitely.
So then also you do have the functionality where if you want to have an 8x large EC2 instance type, by all means, you do have the functionality to deploy that as well. So what it comes down to is how Rob was mentioning as well, where the flexibility to go through the types of instances that are available to you, see what best fits your needs, and then utilize that. And then you do have the option to modify it as needed.
Yeah, so really quick too, I just wanted to show this picture. What we're trying to demonstrate here is that 8 extra larges equals an 8x large, right? So what this is saying is that if I use 1 X large, I'm using 1/8 of an entire physical server. If I use 4 X larges, I'm using half. And then if I use 8, I'm using the whole thing, right? So that's how we kind of divide up the number of we divide up our instances when we time slice people into them. Is that we actually give you the ability to pick how much of it you want, all the way up to picking a completely full piece of hardware. So if you pick an 8X large, you are the sole resident of that server, right? You have all of those resources dedicated to you. Whereas if I just 1X large, I'm going to have a smaller slice of those resources dedicated to me.
And then with AMIs that we have, so think of them synonymous to templates that are available to you in the VMware space. So let's say you want to deploy a VM from a template. In this case, you can deploy from AMI, and then you'll have an EC2 instance up and running. So there's a variety of AMIs that are available to you. Different types of OS flavors that are available to you as well. So if you need something where it already has Windows installed onto it, or it already has a Linux OS or installed onto it, you don't have to go through that process of necessarily deploying an EC2 instance, then booting it up, adding an OS to it, going through that whole configuration. So synonymous to the template functionality where you're deploying from a template, with an AMI, it has everything pretty much for the most part set up as far as the OS is already installed onto it. And then you do have, again, with AMIs, the multitudes of AMIs that are available to you. You do have the flexibility to utilize volumes as well. So if you need to mount different types of storage volumes to your instances, you do have the flexibility to do that as well. So like in the VMware space, if you need to add a disk, maybe you're adding another VMDK to your VM. In this case, you do have the option with your EC2 instance to add additional volumes as needed to it. And this is just showing you where you could have, let's say, a C drive, D drive, multiple volumes that are going to your VM. And then you do have the functionality to even take it a step further. If you need snapshotting set up, you do have those options available to you. Well, if you need it to be backed up to an S3 bucket, you can set that up as well.
Yeah, so going back to the overcommitment, right? You get what you pay for. T2, like I said, is the exception to that rule. Right sizing, I kind of already hit on that, but just the idea of, remember, just make sure that you use the right family with the right instance size for the use case that you're using. We do have we have an assessment tool that we can actually help you use, or just use your typical monitoring systems, right? Kind of figure out what your actual, peak utilization is, and then kind of size from that. Because, when we work with VMware, right, we're always typically going to oversubscribe a little bit. The economics of building vSphere clusters on premises, it really require us to do some level of oversubscription, right? Typically 2 to 1 for CPU is kind of the rule of thumb, 4 to 1 for memory. When we sell you access to an EC2 instance, other than T2, we will not oversubscribe those resources. So if you go and you spin up a C4 8X large, yeah, that capacity will just sit there. We won't ever touch it. It's yours, but you're going to pay for it, right? So that's where sometimes people get into this thing where, hey, my cloud bill is really high, and then we go and we do a well-architected review and we take a look at it, and it's like, well, most of your instances are idle. And we actually have tools that will tell you that. We have a tool called Trusted Advisor that will actually say, hey, here are these 6 EC2 instances that we've noticed over the last 3 months, their utilization is very low, right? And so pay attention to those alerts and actually, make sure that you are using those alerts, and also use CloudWatch, our monitoring system, right? Every instance you fire up with EC2, we give you a free monitoring system called CloudWatch. You get 5-minute metrics that don't cost anything extra. Right? So you can instrument that. You can use alerts to use auto-scaling rules to actually add more capacity if you need it or shrink it down. You can use CloudWatch to send you emails, send you alerts, or even export all of our CloudWatch metrics to your existing monitoring tool. If you're using something like SolarWinds, or you're using something more advanced like HP OpenView or SCOM, you can actually feed those metrics from our monitoring system into yours and then use that for decision making. So we give you a lot of visibility into what you're using and how you're paying for it. So just make sure that you're paying attention to those metrics. I will say as well that most customers tend to find that they bring over all their applications and then they start working on them in AWS, and then eventually they kind of start to figure out where the sweet spot is. But you have to use these tools in order to do it. Yeah. And then the other thing that I wanted to bring up as well is we have 2 different kinds of storage actually for EC2 instances. We have our EBS volumes, which is just a block disk, right? It's just any kind of disk device that attached to a server. But then we also have something called instance storage, and the instance storage is kind of special. EBS is a network-attached system, storage system, right? So we actually will provide, especially in the higher power instances, a dedicated network for I/O to go between your block storage and your EC2 instance. But some customers have use cases where they need to use a lot more storage or a lot faster. They need more I/O, like 100,000 IOPS potentially local right on the disk. So this is where instance storage comes in, where we'll actually connect an NVMe storage device directly to the hardware. Yeah. So when you spin up that EC2 instance, you will have storage available to you on that device directly on the bus that's really fast. The catch is, with native EC2, is that instance storage is ephemeral. And what I mean by that is that while that instance is running, that storage is there and it's there for you to use. But when we shut it down, one of the things that we do, unless you're using what we call our dedicated host, is we don't guarantee you're going to come back to the same piece of storage or same piece of hardware if you shut that instance down and start it back up. So anything that you put on instance storage is considered to be ephemeral, meaning that it goes away when the instance powers down. Right? So there are good things and bad things about that. You just have to make sure to understand the use case when you use instance storage. It's like, hey, I'm going to spin up one server and put all of my critical data on the instance storage. That would be a bad thing, right? But if I want to have a distributed Cassandra cluster, or say I want to build a hosted VMware service in the cloud, I can use instance storage to provide that storage because maybe that VMware stack might bring something additional to protect my data across multiple nodes. So just making sure to put that difference out there because it really tends to trip people up sometimes.
So elasticity. So we did mention where you can have your environment as far as your EC2 instance automatically scale out. So you do have, first of all, load balancers. So the application of load balancer is available to you. So let's say you have a particular application, you want to use different types of EC2 instances behind it, and you need to load balance it from that standpoint. You do have functionality to be granular from an application standpoint as far as the type of application or type of data that's coming into it, where you can utilize the load balancing functionality. And then with the network load balancer, that's available to you as well. So kind of like your typical way to do load balancing today on premises. You do have that functionality that's available to you in AWS as well. And then with the classic load balancer, that is available. So let's say you want to set up multiple EC2s behind it, EC2 instances behind it, and then you want to set up particular load balancing rules. By all means, you have that functionality available to you to leverage as well. But taking it a step further comes down with auto-scaling. So let's say you have peak periods of demand where people are accessing your EC2 instances or multiple EC2 instances. But you need that to grow at certain periods of time. So what we do in that case, rather than manually deploying multiple EC2 instances as needed and having to worry about that, you do have the functionality to have that automatically done for you with auto-scaling rules. So it's elasticity on demand when you need it. You choose when, you choose how, and you choose when to stop it. So there's going to be predefined rules that you do configure when you go through the setup process. So it's not like you just set up an auto-scaling rule and you have certain threshold that's reached, and then it will deploy multiple EC2 instances, and they're just up and running. But when you're done using them, what do? So again, with those thresholds that you set, you can automatically set it up where it gets rid of those particular EC2 instances once it's done utilizing that certain threshold period. And then one of the quick tips that Rob wanted to hit upon as well is where you can scale up for demand and scale down slowly. That's one of the beauties behind auto-scaling that's available to you as far as functionality that it comes down to.
Yeah, so a couple of quick things I just want to mention is application load balancer. Think about that as layer 7, right? So if I want to do route-based load balancing, or I want to do cookie manipulation or things of that nature, application load balancer is kind of the default that we're hoping customers will go with today. Network load balancer is designed much more for high throughput, high scale load balancing. Gives you actually the ability to get a static IP address for the entry point for your load balancer, whereas the application load balancer is using DNS-based failover for its high availability to access it. The classic load balancer is being deprecated. You can still use it. We're not going to take it away anytime soon, but it's one of those things where, really take a look at what you're trying to do, right? What do I want my application, how do I want to influence my application using load balancing? How do I want to route users to my backend servers? What kind of health checking am I going to be doing? And then the scale up for demand and scale down slowly with auto scaling, that's really important because what you don't want to have happen when you build an auto scaling rule is you don't want thrashing, right? So let's say, for example, I have a really spiky demand, right? And I have a bunch of users hit my servers and auto scaling scales up. If I scale down too fast before the next wave of users hit it, what ends up happening is I spin up new instances, right? And I'm doing this shut down, spin up, shut down, spin up. That actually gets expensive because the minute you start an instance, you've paid for the first hour, right? So you really have to understand that behavior of how auto-scaling works when you're adjusting these rules and ensure that you're scaling down over time. So that way, if you have spiky utilization during that workload spike, auto-scaling isn't hammering, starting up new instances constantly, right? It's just coming down over time. It's actually smart. It will terminate instances as it scales down that are closest to the next billing hour to save you money to make sure that you're getting the maximum of what you paid for, things of that nature. But you just have to take that into consideration when you build these auto-scaling rules. And we're obviously, from an SA perspective, that's what we're here for, is to help you figure this stuff out.
So this is just showing you with auto-scaling how you have that flexibility to add the additional EC2 instances as needed, and then it can scale down as needed as well.
Yeah, and I would also just really quick say, too, is auto-scaling, and it's one of those things that people get scared of sometimes because they're like, oh, this is where my runaway cloud bill is going to happen, and I'm going to spend a bunch of money. But there are caps, right? This is you tell us how many you want, and you want to stop, right? And there always should be a stopping point. It should never be open-ended. It should always be one of those things where it's like, all right, once I get to a certain point, and I've scaled additional capacity into my application, if I still need more, then chances are something weird is happening, right, that I haven't typically anticipated or experienced. Like someone's DDoSing me, there's a race condition somewhere in my application, someone's putting some kind of scraper, and that's where you have to really get manually involved at that point, because the automation will take you to a certain place, but you need to put some kind of a manual checkpoint in there at some point for rationalization and kind of sanity, right?
So from the storage side, we have Elastic Block Store, which Rob did mention earlier as well. So it's akin to VMDKs and the VMware space. So just like our instances that are offered to you, you do have a variety of types that are available to you from Elastic Block Store space as well. So with GP2, they're SSD backed. It's a standard option that's offered as well. And then you do have the option to have provisioned IOPS, which are SSD and guaranteed from performance standpoint, and thick SIOC as well. So if, let's say you have performance-based application where it needs to have certain quantitative of IOPS that are met, you do have the functionality where you can utilize provisioned IOPS to guarantee that for you. And then there's also magnetic storage options that are available to you. So traditional magnetic storage, you do have the functionality available to you to leverage those. And then instant storage is also available to you as well. So with the Elastic Block Store, you can see where you have a multitude of varieties that are available to you that best fit your needs. So it comes back to picking and choosing what makes sense in this situation for your application or your workload that you're running on the EC2 instances.
So how many people in here are familiar with object storage? Used S3 before? OK. So object storage is a little different than block storage, for those of you who aren't familiar with it. Let's take an example for a second and think about a Word document, right? So I have this document right here, and I want to change the first letter of this bullet point. So I go in and I go into Word and I change that letter and I save it. If I'm using a block-based storage system, underneath the hood, the operating system is basically translating that write request down to a very small allocation unit on the hard drive. And it's just updating that little allocation unit or that block, and then it goes about its day. So it's very fast, very atomic, very quick, right? But one of the challenges with a block-based file system is that they don't scale. After you get to a certain point, in the multiple terabytes now, they have gotten better, but they still don't scale. You start running into issues like, let's say, for example, I wanted to write 1,000,000,001 kilobyte files to a block-based file system. Anybody in here think I could actually make that happen with a default formatted file system? No, right? I'm going to run out of inodes. I'm going to have file allocation table problems. I'm going to have all kinds of I/O issues. So when you start talking about scaling huge amounts of files and you want to make them available to very large numbers of people, you have to decouple the storage and retrieval of the actual objects from the metadata itself. And so this is where object storage comes into play, right? So the idea is instead of when I change this one letter on this document, what I'm going to do is I'm actually going to save the entire document over again as a different version. Because all I'm doing is just storing blobs of information. And then what I do in my metadata service is I change the pointer that says this is the new version of that object. So it's really fast because I've decoupled those two operations from one another. So in S3, which is our simple storage service, we give you the ability to create these very large-scale systems we call a bucket, which is basically a folder. It's a container for information. And you can put any number of objects in that bucket you want. I don't have to go back and try to hack in more inodes into a file system table later. Right? I can store objects anywhere from 1 byte in size all the way up to 5 terabytes. I actually recently worked with someone who's trying to copy 1,000,000 1K files to a snowball. And it was incredibly painful, right? Because that many files, it's very, very time consuming to copy. But I can create as many objects as I want, and I can parallelize those operations using object storage. Because now instead of accessing them using a file system call, I'm using HTTP calls. It uses HTTPS endpoints. So we actually have FIPS validated endpoints that you can connect to use FIPS validated encryption. And the protocol that you use to talk to this is actually an HTTP object protocol. The durability is 11 nines. And so when I say durability, defining durability versus availability, meaning that durability means I will not lose your objects. And if I remember the math correctly, I think if you store 1,000,000 objects with us, you'll lose one every 656,000 years or something like that. So that's what 11 nines of durability means. 99.99% availability means how your data will be available to you through the S3 endpoints, right? So it's 48 minutes a year or something like that. And we're storing over 2 trillion objects now in our object stores every day with trillions of requests. Like you'll hear a lot of weird statistics about AWS and how big it is, but S3 is one of the largest services we have. It's actually the second oldest service that we have, the first being SQS. This was launched in 2006. And one of the really neat things about S3 is that it's actually one of the most stable APIs in existence. Most storage vendors, irrespective of who they are using S3 compatible storage APIs for object storage because it has been so stable for so many years.
So on the database side, you have a different variety of options that are available to you. One value of using the cloud is you can remove the undifferentiated heavy lifting that comes with managing a database. So for example, we have Amazon RDS. It's a managed database service that's available to you. If If you want to leverage it from your MySQL standpoint, Postgre, MariaDB, SQL Server, you can bring those types of databases into RDS. If you want to migrate it in, or if you want to deploy a new database that leverages any of those flavors of database services, you do have the variety to do that as well. So we patch and manage it for you, so you don't have to worry about that anymore. So as far as pretty much the admin standpoint, where you would have to go through the patching of it, managing of it, even the backups of it, we take care of that for you. And we do have the functionality where you can replicate it across multiple AZs as well. So by default, that is there as well, where you have the functionality to replicate it across AZs. But if you want to set up like a master slave, you do have the functionality to do that as well. And then also, Amazon DynamoDB is available to you. So it's a managed NoSQL database for you. If you want to utilize it from a NoSQL database standpoint, you can go through the console and deploy it out. Again, it is managed as well, so you don't have to worry about any of the management hassles that come around with running and maintaining a database.
Now, one thing I'd add to databases, especially when you start talking about VMware and AWS, right? So as you start looking at migrating applications to AWS, this is a fully managed database service with RDS, right? And what this means is that not only is it a fully managed service where you don't have to patch things, you don't have to deal with operating systems or any of that kind of stuff, but we've actually had this accredited at FedRAMP High in GovCloud, right? FedRAMP Moderate in our East-West regions. So you can actually use this service and get accredited, get an ATO for your application by leveraging this service. And your controls for things like STIGs and OS patching and all that other stuff are actually inherited from our accreditation from FedRAMP. So imagine moving a VMware application over that maybe like has a SQL server or something of that nature. I can actually use RDS to host my database, and all of those accreditation hassles are gone for the database side of things, right? And I can just continue to do the same things with my golden STIG'd images and stuff like that for my VMware VMs, but I can talk to this database with a super high-speed link between my VMware environment and my AWS environment. But that whole kind of idea of the shared responsibility model where I'm responsible for the stuff I'm responsible for the security of the cloud, you're responsible for what you put into it. By using managed services like RDS, I move that demarcation line up. And I take more, as at AWS, we take more responsibility, right, of managing the infrastructure and the services for you, which frees you up. Like if you're a DBA in here, I think most DBAs would agree that it'd be better to have more time to optimize queries and fix indexes and make the database run better than it would be to do patching and backups, which most DBAs I know spend way more time on than they'd like. So, really quick, because we're getting low on time here, we'll give you guys a chance to ask us any questions. Identity access management is our identity system for access to AWS resources, right? So this is not access to your applications. This is how you control access to the actual AWS control plane. This is really important to understand because, just to be candid, like most times when you hear about things happening, with people's stuff getting exposed, this is because this was not done correctly, right? So we've put a tremendous amount of engineering and effort into building these policies easier and understanding when they're not working correctly. We have policy simulators. We have the ability to do testing and debugging of policies. And we also have managed policies that you can use where it predefines specific roles that you can take a look and say, okay, I want to give someone the ability to manage S3 buckets, so I have this S3 access policy, and then I can go in and customize that to specific persons and specific buckets. You can create users, you can create passwords, you can do token access keys, and you can also federate this, importantly, especially for people in compliant environments, you can federate this to your Active Directory or your existing identity and access management system, and very easily using SAML authentication, enable CAC and PIV authentication, right, which is privileged user access typically requires some kind of token like that. The other piece here as well is the key management service. So as you're storing your information in the cloud, one thing you're going to get asked is, how are you protecting that data at rest, right? So our key management service integrates with most of our services today. It integrates with RDS, it integrates with S3, it integrates with our Elastic Block Store, and it is basically a fully managed hierarchical symmetric key envelope encryption system, which says, what in simple language means that every time I store a piece of data in AWS, if I elect to encrypt it with KMS, that piece of data gets a unique encryption key created for it. That unique encryption key is encrypted and stored as metadata with that object, and then the master encryption key that decrypts the data key is stored in a very secure HSM that we manage for you. That HSM has been accredited by the DoD to work at impact level 5, so national security system and below. We've had a lot of other accreditations of that system, which I could talk to you about later. There's also a 48-page white paper on the crypto in the box. And what's really, really cool is we actually have a NIST certificate now for the HSM that manages that service. So it's the first ever NIST certified device that Amazon's created. So I get really excited about it because it's really neat, and I'm a nerd. But using that, all of that complex stuff, which this is the coolest part, is a checkbox. It's literally a checkbox now in S3. If you go to S3 and you create your bucket policy, you can check a box that says encrypt all objects that go into this bucket using a KMS key. It's not hard to do, right? And it's very powerful. So as you can see, I get excited about it.
Yeah. So as far as best practices that come down to utilizing AWS, think about locking down the root account. Use multi-factor authentication. You do have the functionality to set that up as well. You will receive notifications or recommendations around that as well. So the MFA is not just for logins. You can use it to avoid mistakes that people make as well. So think about that from that standpoint. And then you can also set up individual user accounts. So be sure to go the path where you're not just sharing the root account with everyone on your team. Set up individual user accounts as well. And then you can utilize account hierarchy as well. So think about how you want to organize your accounts. So that's also going to help you from a billing perspective. And then always be sure to use tags. Majority of our services do have that functionality where you can use a tag. Be sure to use that, because when it comes down to questioning what was done or from a billing perspective, you have a quick, easy way now to just index or search for it as needed. And then you have a Trusted Advisor that Rob did mention that's available to you. Also the Personal Health Dashboard that's available to you as well. So that's going to give you a quick overview of maybe what might be wrong and what recommendations you should take and the actions in order to fix that as well.
Yeah, I would just say with the account hierarchy, make sure that really you pay attention to that, because how many people are in here work for like an SI or a contractor? A couple? All right, so when you have an account, right, let's say, for example, I get tasked to create an account and create an infrastructure for someone. If I put that account in a billing structure where I have other stuff that sits above it that belongs to me that I don't want to give to my customer, it is very tough for us, especially with GovCloud, to decouple those things. Right? So really, when you start talking about rolling your billing up to a single bill, there's a lot of benefit with that. It makes it easier. You can get invoicing. You don't have to swipe a credit card, that kind of stuff. But the downside is that if you don't design that correctly, later on, if you need to break that apart, because of a merger or an acquisition, or a government person wants you to have the billing be paid by somebody else, that can be a challenge, right? And I've been through those challenges. So just think about that. Again, we're here to help you. We've got a whole concierge team. That's their job. That's what they do all day long. And then tags is also a very powerful security tool, because tags give me the ability to very granularly define permissions on each individual resource, right? So those IAM policies I talked about earlier, you can use tags to drive that. So if you have an account where you have a bunch of people sharing infrastructure, you might have like a development team, a QA team, things of that nature. Those tags will give you the ability to granularly assign rights and roles to people in your account. And they're also phenomenally valuable for billing. So if you have a shared infrastructure and you have a few people using an account, those tags can help you break down who's spending what and where the bill is actually going.
Yeah. So you want to hit upon this one? This is a good one as
well.
well.
One of the most powerful things about cloud is the ability to be consistent. I can build the same infrastructure every single time. And one of the ways that we do that is using infrastructure as code tools like CloudFormation. So CloudFormation is our templating system that basically gives you the ability to design and build your infrastructure as a declarative template, right? So it's in a declarative language. This is using a YAML example. And basically what I'm doing is I'm just defining some parameters and a resource here that when I execute this code using our CloudFormation system, every single time I create this resource, it will be created exactly the same way. Every time this resource is modified, I will get drift remediation notifications now that tell me that this resource has been changed. And the beautiful thing about this is unlike typical change control where I write up a template in a document and then I just kind of trust that someone did what they said they did, if I change my infrastructure using infrastructure as code, I can actually version my infrastructure using a source control system, for example. So every time I add a new resource to my AWS account, instead of going in the console and clicking through it, I can actually just change a piece of code and I can look at a version control repository and see the history of those changes that have been made. Right? So infrastructure as code is incredibly powerful for security, for compliance, for consistency. If you're starting to work with a development team and implementing DevOps type processes and working with agile development, consistency in infrastructure is huge because they cannot determine what the change sets are from one build to another if the infrastructure changes. Right? And that's one of the biggest things that slows things down. And it also helps you build stuff faster. Right? We have one customer where they were spending weeks building out a single test harness for a code test. They're now down to 15 minutes. Right? You execute the CloudFormation template, it starts running, and off you go. So very powerful tool.
Yeah, it's actually, from a CloudFormation standpoint, it's actually leveraged with VMware Cloud on AWS to deploy your hosts that are needed for your SDDC as well. So that's a fully automated process on the back end where we're leveraging CloudFormation. So as far as common challenges with the hybrid cloud adoption,
4 minutes.
yeah, it's going to come down to your having to deal with multiple VM file formats, having incongruent networks, having operational inconsistency between on-premises and in the cloud, and then having to learn new skills or utilize different tools between both environments. And then lastly, having multiple cloud controls or monitoring mechanisms in place. With that, we're removing these challenges with VMware Cloud on AWS as well. So from a high-level service overview, you're going to have where the service is a VMware SDDC. It's running on bare metal. You have direct access to native AWS services as needed. You can utilize the global AWS footprint as far as the reach and availability. It does have support for containers and VMs. So pretty much any type of VM that you're running on-premise, you can just vMotion that over to VMware Cloud on AWS. And it does allow for on-demand capacity and flexible consumption as well. And then you do have the flexibility to tie it with your on-premises environment to allow for seamless workload portability. It is sold, operated, and supported by VMware. And then with the native AWS services, you have the option to integrate them as needed. So it's pretty much pick and choose what best fits you from that standpoint. With the software-defined data center, you do have multiple options that are available to you. So you're going to have your ESXi bare metal hosts. Then you're going to have your vCenter server appliance that exists on top of that. NSX is going to leverage it from the networking standpoint. You do have the functionality to set up different logical networks as needed as well. You're going to have a management gateway for the management of, your, for example, your vCenter server appliance. And then also on the ESXi side of it as well, compute gateway is going to be where your VMs will reside. And then with your customer-owned AWS account, you can have what's called the cross ENI, which will communicate with any of those AWS resources in your account. So let's say you want to have a VM access a database, RDS, for example. You could leverage that as well. And then as far as what's next, with AWS, you do have the option to utilize the free tier. And it is available to you at no cost. So you need to have an email address, valid phone number, credit card, just to validate that you're a real human on that side. And you're up and running. And then as far as training, so I know Rob is very fond of that as well from that standpoint.
Yeah, I know. We have. Oh. Sorry, I had a cough a second ago. We have a lot of training options. We have our paid training that we do, obviously. We have a great program there. We also have a lot of training available on our website. If you have any veterans in the room, we have a AWS Educate for Veterans where we'll actually help pay for your certification costs, get you some free training. Every one of our conferences that we do, summits like this, our reInvent conference, if you go to YouTube, you can actually see every session, right? So, I mean, you could spend weeks watching all of these sessions and learning about AWS. I would highly recommend, if you're starting to go down this path, to just go ahead and get certified. We have 5 different certifications that are our core certs, and we have 3 specialties, but our SA, Solution Architect Associate exam, is a fairly good place to start. And even if you don't take the test, download the blueprint for the exam and use that as your roadmap for self-study as you start to understand AWS natively. Third-party training, we also have a couple of great companies out there that I personally use, A Cloud Guru, Linux Academy, very inexpensive training, and it's actually pretty high quality that you can use to get in there, get lab help to actually build stuff. And then the free tier, I mean, it's literally, most of our services have a very, very good amount of usage that you don't have to pay for. I went through the entire Solutions Architect Associate study path, and I think I spent $40 in AWS usage charges. So it's a really, really great benefit. And then, with VMware, obviously, the hands-on labs is a great place to go and get experience working with the vSphere, the VMware side of the provisioning systems and everything else with VMware Cloud on AWS. So.
Yeah. With that, thank you for your time. So appreciate it. If you guys have any questions, we'll be sticking around for a little bit as well. So, and then one quick thing is there's also a survey that if you don't mind, if you could just complete that at the end of the session as well, just to give some feedback. Appreciate your time. Thank you.